Okay. Lovely. So I think everybody's in that has arrived thus far. Obviously, more people will arrive during the session, but that's absolutely fine. So I'm going to kick us off. Good evening, everyone. Thank you so much for joining us today. For those of you who don't know, my name is Abby. I work with Barry Cranford, who's the founder of the LJC, and I have the privilege of welcoming you to this evening's event. For those of you who don't know, the LJC is just one of the communities run by RecWorks, which is a tech recruitment company with a big difference. As a company, we believe that recruitment can really be a force for good in the industry beyond just placing people in jobs. We have a particular focus on learning, mentoring, and personal development. From our perspective, if people want to learn and others want to teach or share knowledge, we are more than happy to connect those people through our communities and events. We see this as giving back to those we've worked with in the past, but also paying it forward to those we hope to work with in the future. So far, we have run over 700 events for engineers and developers within the LJC, for students, graduates, CTOs. We have run conferences, lightning talks, hackathons, all sorts. We have just made our 4,000th introduction through our Meet a Mentor program, which is really exciting. As I've already said, we love to give opportunities for people to connect, and this event is part of that. If you would like to know anything else about any of our communities or events, please do get in touch with myself or Helen or Barry, and we can take it from there. Just to let you know, tonight's session will be recorded, and you'll be able to find the recording on YouTube. If you look for RecWorks, it will be on our channel in a couple of weeks, most likely. Or you can connect with me on LinkedIn. I'm going to put my profile in the chat, and that way I can send it you directly when it's available. So I'm happy either way, whatever you choose. With no further ado, though, let me introduce Steve, who's here to speak to us tonight on Log4Shell, Armageddon or Opportunity. Over to you, Steve.
Thank you. Thank you. And thank you for, telling everybody about RecWorks. I think they do so much for the RJC, so it's good that we're promoting it. Yeah, cool. Okay, so thank you for coming and listening. Well, I'm sure you'll enjoy it one way or the other. You're a bit of a guinea pig because this is quite a complicated talk, and I'm not sure just how far it's going to go, but the RJC has always been a good sounding board, so I'm going to do the talk. Hopefully, if you want to ask questions, stick in the chat, and I'll see whether we can get to the end of this and put some space to talk. Otherwise, maybe we'll set something else up. It is a complicated subject, and there's a bunch of stuff floating around. So, as they say, when a momentous thing happens, we may remember where we are. And I remember the 9th of December, that just looking at this thing that it came in about Log4J. So I work for Sonotype as a developer advocate. Prior to that, I spent a long time at IBM doing Java virtual machine development, and I've been in the Java space for, well, pretty much since it began. And so, we're used to the occasional Java vulnerability turning up, and we're used to dealing with it. But to be honest, those of us in the Java space who keep an eye on some of the other environments, the nodes and the Pythons, we're always going, oh yeah, we're not, Java's better, Java's safer. And then 9th of December, this little thing came past, and I read it, and it sort of clicked. And then suddenly it was like, oh, because we started digging into it. 10th of December, the next day, well, the world had gone mad. Those of you who have been involved in trying to fix this, I'm sure will appreciate exactly just how quickly it went mad. There was a lot of conversation around Log4j, the vulnerability that we're going to talk about, very much, and it got out of all proportion. And one of the reasons for that was because it's quite complicated as to whether or not you can be impacted by all of the various attack modes that this vulnerability enables. And also just so much noise, I think we saw so many people making rash statements about it. sorry, 10th of December, we began to realize that this 0-day vulnerability that had been announced was going to be big and difficult. And it started to grow, because one of the things that you have to understand about Log4j is not so much the attack itself or the vulnerability, which is pretty bad, but it's also the timing. One of the things that has happened in the last 18 months has been an incredible increase in the type and scale and sophistication of attacks. We're moving away from many of the traditional attacks that we've seen in the past towards very sophisticated ones. You'll have seen the growth in ransomware, and you're probably maybe marginally aware of the fact that there are now more conversations around attacks that are driven by state actors. So you've probably read about Russian attack groups and Chinese attack groups, and you can expect that other countries all have the same thing. Because what's beginning to become apparent is that the next challenge in terms of, the next battlefield, so to speak, is going to be on the internet. Because if you can get in and influence people's infrastructure, if you can get into the systems and control them and manage them, even if it's very quietly installing malware, etc., then it puts you in a position of power. And so everybody's waking up to the fact that software is quite vulnerable. And then when a vulnerability like this one comes along, everybody jumps on it because of the potential to get into somebody else's system and insert malware, steal data, and all those sorts of stuff. And so it has grown. The other reason it's grown is because it's trivial to exploit. And I will give you a demo or two of how easy it is to exploit. So we go from nothing to enormous amount of attention, being exploited already. Thousands and thousands of systems were being attacked almost instantly. It got so big that it ended up on the news, which obviously for a Java vulnerability is pretty scary, but that's how big it got. And then it got even bigger. The US cybersecurity infrastructure team agency started talking about it and saying, you have to do something about this. And you may have read some of the directives that are coming through from government organizations about making sure that you're properly patched. And it even ended up in the White House, and some of the large tech groups were invited to come along and talk about it. Now, what's interesting is that, as I said, this is like a perfect storm. So we have Log4j as a vulnerability. We have this growth in new types of motivation for attacks. And it all comes down to things like Log4j, which is open source. We have these people who are contributing their time and effort to create the technology that we use. You've probably seen the numbers, but it's something like 90% of an application. It's actually made up the dependencies, open source. And of course, that's all provided free by a large community. And that community is now beginning to get pressure to change its behavior, because suddenly we're seeing how important it is to deal with Log4j. And that's having some negative effects. You may also have seen some misguided statements by companies who are talking to open source providers, the committers, and as if they have some support contract, and they're not aware of the licensing terms that actually open source is made available. So there's a whole bunch of stuff going on here that all revolves around how we take open source forward in these new environments where the trust that we used to be placed in our communities is being eroded by some of these bad actors, and we have to figure out how to get that back and how to deal with it. So you have that environment, and then you have something like Log4j, and as you can imagine, there was a lot of panic, and a lot of that is rightly so. But you can see why, like Log4j, in many ways has become just the wrong thing at the wrong time. And it turns out, based on what we think so far, is this may be, in terms of ease of use and widespread usage, because in the Java community, probably everybody or almost everybody uses Log4j. It's turning out that it is everywhere and it's trivially exploitable. So if you can find out that a system's got this vulnerability, then on the worst case, and I'll show you the worst case, you can easily get a complete control. You have what would be called an arbitrary remote coding tag. So, what do we get to? Yeah. And recently, yesterday or the day before, I was reading about this. It's been out for a little bit, but literally Log4j turns up in a Tesla. Really? Well, if it is true, or whether it's the applications, doesn't matter. You can see the exposure. And again, we'll explain why this is feasible. But where Log4j is in all these places, then that vulnerability is there. Right. So the vulnerability, well, it got reported 9th, 10th of December, and the Log4j guys did what they always do, which everybody does, is that they worked, very hard, and they got a fix out. We have a CVE, so you can go track it. And since this one's come out, there's been a couple of others on the back of this. But actually, at the end of the day, the advice is still the same. The advice will still be moved to the very latest version of Log4j that you can. The problem is that associated with this vulnerability being reported is the realization that actually it's not so much a bug, it's actually a feature that was put in for good reasons. And that feature has been around for some time. So this isn't a newly discovered vulnerability in that sense, it's a long-running vulnerability. And some of the other aspects of this, the JNDI vulnerability, which you may have heard about, has been around for some time. And the security groups, the hackers, etc., have called this out, but we haven't been that good at fixing it. And of course, now we're in a position where we really, really have to. So today, I'm going to try and cover as much of this as I can. I may bail on some of the last bits if I've run out of time, but they are important to discuss. So let's look through what a Java exploit looks like in general. And then I'll show you how Log4j shell exploit works. I'll do the demo, and then I'll go through all there is there, what it means and how it happens. So bear with me. Right. Okay. So Java exploits. And this is probably true for most exploits, but let's talk about Java specifically. There are two objectives. One is this arbitrary remote code execution. The best thing as a bad guy that I want to be able to do is get into your systems and run any code that I want. If I can do that, if I have complete control, if I can get your command line or the moral equivalent, then I can do whatever I want. If I can install code, if I got full remote control, I can install malware, I can read your data, I can change your data, I can do whatever I want. And most of those arbitrary remote code executions, these RCEs, are built on using either Java serialization, which is complicated, but certainly not impossible, or places where there are what would basically be text to execution. So scripting, there are places where you take text code, you take text, maybe it's an XML tag, and use that tag to do some reflection, load up some classes, whatever. All of those places where some form of text data ends up driving code are potential places for getting a remote code execution. And there are many, many instances of this. And so that's my number one goal. And also I'd like to do it in such a way that I don't leave any trace, because if I can get into your system and do what I need to do without you knowing, and that may be immediately, or it may be forever, then I win. Because if I can get into your system and leave no trace, I can come back. And if I'm dropping malware in, then of course I don't need to know either. Now, if I can't get remote access, then I still want to see whether I can get at your data. Can I steal your data? Can I change it? Can I insert data, etc.? Can I get at your secrets? Because if I can steal the data, then maybe I can use that somewhere else in a different attack. So it may not be as good as being able to getting into remote code execution, but at the very, I've got data from you. And that's gadget chains. And I'll show you a gadget chain. That's a pretty straightforward thing to do. But gadget chains, as you'll see, gadget chains are a sequence of Java objects that rely on the code that you have running, the objects that the whatever's in your class path. Whereas the one before, the main objective with remote code execution is, can I get to the point where I can load my arbitrary code? So can I do that? And if not, can I get in? Can I run any code? And so that'll be through gadget chains. A lot of these things get enabled by human error, and I'll show you what I mean by that later on. And just generally, can I have some effect on your system? So I'm looking for either one of these or anything in between. Okay. Now, I should add that when you think about attacks, it's not the old thing of, it's not a script, it's not a 15-year-old, guy on his Xbox who on the side is breaking into your systems. And though that still happens, that's nowhere near what a modern attack system looks like. Now we're talking about very large botnets, millions of devices with very sophisticated tools. So as soon as Log4j came out, these botnets were enabled with that vulnerability. And this is going to go through and probe every way that it can into your system. And these things are well refined over the years. They know exactly what the best way of getting into your systems, what your endpoints are, etc. And I always say that the best way to think about this is, imagine that there's basically a burglar going around trying every single door and every single building around the world 24/7 continuously. If you put your application on the cloud and it's got a public endpoint, it's going to get probed. If you put your application on a private network inside your corporation, it's still potentially findable, because there's always the possibility that one of your systems has been compromised and you get piggybacking. So wherever your system is, in a car, on the internet, box under your desk, it's possible that these scripts can get to you. It's a scary thought. What's more scary is that the way they get in is fully engineered. So there are very good tools and services out there that have been built up over years from pen testers and just from the test community that work out how to drive your system. There are things called fuzzing, and here's some examples. So the OBOS team have some examples, but these are tools that you can use yourself. If you're testing an API, you would try various ways of trying to break it, and you might try different HTTP verbs if it was an endpoint, etc. And that's what these bots are going to do. These bots are going to be using sets of common understanding, common techniques to get into your system. And it's fully automated. And then once they make a connection, then they can deliver payloads and do further pieces of damage. But it's built in, right? There's no human being involved in this. It's millions of botnets probing all the time. And they have lots of sophisticated tools. There are all sorts of ways that they can get into your API. Fuzzing is the general term. And then there's a whole bunch of basically dictionaries. If you've come up with an endpoint name, then somebody else has already thought about it. There are ways of driving your data in ways that you weren't expecting. And this is very professional. It's well organized. There are proper tools. So you have to understand that the attacks aren't 15-year-old in the bedroom. This is a very well organized, very sophisticated, well-trained attack system. And it's not just your URLs, it's your JSON payloads, it's your XML payloads, it's your binary payloads. There have been examples of attacks being done by uploading corrupted images with all sorts of different payloads in. There's all sorts of ways that you as a developer probably wouldn't have thought at that are being used to get into your system. Right. Scary thought. Okay. And Log4Shell is a gift. because it's been there since 2014, 2015 as a feature for us to use. And no doubt it has quietly been exploited for those many years. And then when it got publicly announced, of course, the rest of the world caught on, and you had this massive increase in attacks. And it's not going to go away, right? You have to defend against this. It is too useful for the bad guys not to keep probing to figure out how to get into your system. Okay. So let's talk about how this happens. Now, I'm going to assume you all know about Log4j, but we're going to talk about it quickly. You may not be using Log4j specifically, maybe use some other logger, but their principle is pretty much the same. You have some factory or object that you're going to use as a logger, and that will have some configuration behind it that you'll use to store your data. And somewhere in your code, you'll have logging statements. You'll do it. You know, the demo I'm going to show you has got a whole bunch of logging statements in. It's very important, especially if you're running systems that are not easily debuggable, that you have good logs so you can see what happened, what behavior your system was doing. So in the event of something going wrong, you've got data. Okay, and there's absolutely nothing wrong with that. That's what it's all about. So you have these logging statements of different types with Log4j, and of course it ends up somewhere in a log, whether it's in a file on the machine or it's go off to some log aggregator, somewhere the data has been sent off, and it's all been obviously turned from the methods into data. And that's cool. That's very useful. So the first thing to understand is that because it's a debugging tool, we're expecting as developers to put into the log the data that we have. So if we get input data that is going to drive the application in a way we weren't expecting, we would like to log that input data as is. We don't want to change it, because if we change it, then it won't be able to tell us why the application did what it did, because the data is not correct. So quite often, however we do it, we tend to pass it straight through. So whether it comes from a header or a field or whatever, we just go, whatever it is, put it into the log, because that's the whole intent. Okay. Now, Log4j also has some nice little features. So if you're writing an application or a dependency that people are going to use some tool, you might want to put in some logging information about the environment, what versions it's running on, you know, what type of hardware, whatever it might be. And you've got two ways of doing that. You can use it the sort of Java version way, where you would call the method and you'd go off and construct some string and pass it in. And you might do, you know, system.get properties. That's, you know, classic. But Log4j makes it easier for you. And this is good because it's always nice to have it done for you, and especially if it can be done in a more robust way. So what I can do in a Log4j environment is put in the substitution parameters. You can see the $sys Java version, which tells Log4j to do basically what I had in the line above, go off and get the Java version and stick it in the logger. Yep, that makes sense. And then whatever the answer is, it goes in the log. So it's cool. So if I run my application on a Java version, or if my application is run on a Java version that I don't support, then and I can see the logs, I can tell the customer, you know, all those sorts of things. That's what you want to be able to do. So these substitution parameters, there's the sort of mix, substitution process, and there are these things called lookups. You can see a few of them in the white box. The sys one gets you system properties. There's env one, which lets you get environmental variables. And there's even Log4j config one, which will tell you things about Log4j. This is cool, right? You want to put stuff into the log that's useful. And depending where your configuration data is stored or your environmental data is stored, you're going to want to log it. So if Log4j can do it for you, then that's cool. So you can see on the right, that's the list of lookups that Log4j has at the moment. And there's a various bunch of stuff, and I'm not going to touch hardly any of them. But their point is that these are plugins, you can add your own ones, but they're there to help, right? You might want to know if you're running a Docker container, you might want to know what the container ID is. So rather than have to write horrible code, Log4j has lookups that lets you do that. So these are all very useful, right? But as you can see, it's on the list of exploited mechanics. It's the usefulness that's going to bite us. Okay. So let's start to put the stuff together. So we've got an environment where, as developers, we're going to record the data that we're given as cleanly as we can for diagnostic purposes. And we have a process that will take these dollar variable descriptions and turn them into values. So as you can imagine, this vulnerability is driven by the fact that if you put these substitution values in the data that gets logged, even if you as a developer wasn't expecting it, Log4j will execute, will do the translation. And so this is where it all starts. So you want to think about where your data comes from. So you will have seen people talking about headers and cookies and things like that. And that's true. If you log them, I'm logging a user agent in this example. A lot of this stuff happens before there's any security involved. It is simply a call came in, I put some stuff about the REST call down in my log, and then I do whatever happens, by which case it's too late. But it doesn't have to be just, it's not just cookies or headers or REST or bodies from a REST call. It's anywhere the data can be driven. The Tesla iPhone example is driven by having the iPhone have a device name that matches one of these properties, because it gets logged. You can imagine that you've got some application that's running on a device, you want to log the device name, you log it as is. It turns out that somebody's renamed the device name to be one of these, and suddenly you're vulnerable. So it's about the fact that you're logging the data, and then it's about where the data is, how the data is getting to your log. So it could be very straightforward, you're logging the request, or it could be something more sophisticated. It could have got into your databases. You could have data like this in your databases, and at some point, the logger does something and logs it. So it's not only about patching Log4j, but it's also thinking about where the data is and whether you need to go and validate your data sources to make sure that some of these variables aren't in there. But you can see it can come from anywhere. And because of this fact that we're logging the data as is, it's super vulnerable because it takes somebody just to change something to one of these variables. Okay. So that's bad enough. And then it gets worse, of course. So we have these lookups, and there were some really useful ones. And then in 2014, this new one was added, which was for JNDI. And if you use JNDI, you'll know that one of the things it's good for is allowing you to get consistent access to all sorts of different configurations. And that was the primary objective. I want to be able to get JDBC configuration data and log it. I want to be able to get some other configuration and log it. Okay, JNDI would let me do that. And that's what the intent was. It was made it easier to get the configuration, environmental information I need and put it into the log. However, as it says, I'm losing my place, yes. Unfortunately, what wasn't thought about at the time was that by adding the support for JNDI, which is built into the JVM, you also got access to a bunch of other services. So you got access to LDAP, you got access to RMI, DNS, and well, in fact, basically whatever other things were registered with the JNDI setup. But obviously the ones that are most obvious in terms of exploit are LDAP, RMI, and DNS. I'm not going to demo the RMI and the DNS stuff. We'll talk about it, but I'll show you the LDAP thing because of just basically because it's the worst case. Okay. Oh yes, and so if this wasn't worse, if all of this wasn't bad, let me add another thing to the perfect storm. For almost all versions of Log4j, not all of them, substitution processing, dealing with these dollar bracket variables, is recursive, repetitive. If you substitute something and the resultant text also has a substitution variable, Log4j will go around the end. It's got some smarts to make sure that it won't do an infinite loop, but you can imagine that with a little bit of trickery, you can get some interesting things to happen. So the example here is, imagine you have an envar that's called mode. It's a string, which has the value of sysjava version. And then I log in my code, and I use the substitution parameter called env, which gets me environmental variables. So I say, tell me the value of env mode. What gets logged? Well, what gets logged is the actual result of asking for the Java version. So that repetitive recursive substitution is key to a lot of the way the attacks work. So there's a whole bunch of stuff going on here. So here we are. We have very powerful capabilities within the Log4j lookups, which were more than probably we ever needed. A substitution process that is going to help us do more exploitation because of the recursive nature. And as developers, the expectation that we are going to put data into our logs in an as-is state. So it turns out to be field day, absolute field day for everybody. I'm sure those of you who have been involved in fixing it know that. We went from nothing to, basically, if you're a global enterprise, global corporate, in fact, pretty much everybody, 50% was being attacked, and that was what we were measuring. All sorts of variations of exploits, all sorts of different ways of trying it out. And depending which version of Log4j in Java you're running, they have more or less success. Okay, so let's see it in action. Bear with me. Right, says he. Okay, I'm halfway through and I need to show you this stuff. Okay. Okay, I'm going to need some thumbs ups because I need to make sure that this works. Okay. Bear with me while I move. Oh, don't do that. I have, sorry, that one. Yes, okay. So, in theory, I've just did a question for Carsten, which is, to an attacker, what good is it to log sensitive information, i.e. environment variables with database passwords? The attacker usually doesn't have access to the log files. We'll come back to that because it's a good question, but the answer is it's not what you think. Well, maybe it is, you'll see. Okay, so look, I need to explain to you what you're seeing because it's complicated. In the top left corner is an application. It's a Spark Java application. It's been around for ages. It's running as is, apart from it's got a Log4j setup that tells it to log to an HTTP server, which is actually running the rest of the demo. So I have that. I have some hints, which we're going to cut and paste so you can see in action. And I have some checkboxes for all available Log4j versions that are out there, and a whole bunch of Java versions. Now, I'm not going to run all of this, but because I've been experimenting with trying to get my head around what works and what doesn't work, it's been interesting to see that you get various different responses. And at the bottom, I've got some properties that if we get around to it, I can click those to show what happens, because it turns out that there are three properties that you'll see talked about. There are the trust URL code base and the trust serial data, which are related to the JNDI stuff. And then there's a message no lookups property, which, given I was telling you about these lookups, you can imagine is intended to turn them off. Right. So I also have up here a whole bunch of consoles. We're going to keep it on the first one. So I'll just show you an action. Okay. So let's take this item here. All right. I'm just going to paste this as text into this to-do thing. Well, in fact, let's do something a bit more sensible. Let's show you. I mean, the idea is I can use it to do to-dos. And look, I get to-dos, and I can delete them. Right? Nothing magic there. But if I then go and put in something a little bit more sophisticated, like a substitution parameter, here we go. What happens? I actually didn't select anything, did I? So let's kill that. So let's do 2.0 with Java 8 102, something quite old. What happens? Ta-da. And there we go. So now you see a little black blob. I don't know if I can make that bigger. No, I don't see to make it. Hopefully you can see that. And you can see the red, a little diff on the text between what was expected and what was received. And there's a version number. Okay. And there's it in action. That's what happens. Now, you know, whichever one you want to pick, I mean, well, let's try something else. Let's try 2.4. Let's try an older version. Let's try Java 17. Let's see what happens. Okay, and I'll put a different one. I'll put the same thing in again. And let's see. Oh yeah, because I'm on a different 1701. So I'm down here. Okay, 1701. Hey, still working. You can see the little numbers here on the left of the black, which is the Log4J. I can set this up to run all these things, right? But you can see that was pretty trivial. Okay, so let's turn these things off. Let's clear this log and let's go through to some of the others. So let's stay on the latest, the oldest and the oldest, so you can see what happens. So I've got my Java version. I've got my env mode, so I can go and do that. And that will report also. I don't know if you can see that. I'm sorry if it's a bit small. It says production. That's an env that I set up before I ran the application. That's doing what Log4j should do. And as you can see, but it's just coming in from the data that I typed into the to-dos because I'm logging the data that came in, right? So what else can we do? Let me do that. Let me just clear these out of the way. So we want to do some LDAP stuff because that's the more fun bit. So let's see, let's always pick the same ones because it's always fun. Actually, let me show you something else first. Let me do the class path one, because though this is the same as doing the system properties, it's important to see that you get, did I do that right? 102, yes. Oh, I got a timeout error on that one. Let's try that. Let's try a different version. My system is not as robust as it should be. And that's 8U11. There we go. And again, I don't know if you can see that, but I now have a class path. Cool. Well, that's interesting. Bear that in mind. So one of the first things I'm going to try and do as a bad guy is get in and get that class path. I want to know what version of Java you're running, and I want to know what class path you've got, because that will tell me what code I could run as a gadget chain, because if I know what your class path is, I can do that. So let's go back to this one. Let me clear all this stuff out. Let's go back to this one. Let's try this one. Okay, now this one says JNDI, LDAP, blah, blah, blah. It's going to call a server, which I've got running, and it's going to pass in a vaguely innocuous LDAP lookup, and it's going to go looking for an object. So I run that, and here we go. Now, you can see here, there's this LDAP console. This is what my LDAP console is thinking. Okay, so let's just show that it talks to the LDAP console. So what happened here is I put this in, and I put this innocuous thing in. And what did I get in my log? I got, look, again, I'm sorry if you can't see it too much. It says title, it's an IP address, sent us some stuff. And down here is the LDAP server. So what happened was I put in an LDAP call. The LDAP call reached out, returned a string that I put into my data, which is sort of what it wants to happen. Now, in this case, you can see that that substitution parameter didn't change. But if I go to something a bit older, let's go for, I mean, let's just pick something a bit older. Let's do that again. And we're running, so it's the same thing. Okay, so now we're running on 2.11.1 or Log4J 2.11.1. Now that substitution process, the recursive nature has been enabled by this version of Log4J, and now I've got the answer that I wanted. So now what's happening is that initial data that says, just make a call to this LDAP server, makes a call to the LDAP server comes back with another payload, which is another substitution process, which gets run, and because it's all wrapped up another JNDI call, sends it back. Okay, so effectively, if you see down this black LDAP console, you can see a line where the data that I wanted was sent to me. I got your server to make a call to my LDAP server, who then started a conversation with you to get data, all under the covers of one method call, i.e. the logging call. Okay, so what else can we do? Well, let's do, how about this one? Oh no, let's do the gadget one first. Okay, so that was asking for a version. Now we're going to ask for a gadget, and I'll talk about gadgets in a sec. Okay, so what's happening is, again, there is this gadget call, and it's bringing back, unfortunately it's a bit weird, but it says this is a nested list, blah, blah, blah. We'll go into what that code is in a minute. But a gadget chain is where I make a request, and what I get back is some Java objects. I get serialized form, gets deserialized. Okay, and that's what you're seeing. You're seeing the contents of a deserialized object, which was just running, which I got for an LDAP server. Now, I said a gadget chain is one where the data, the objects that you're going to construct are already on your system. So you can do no more than what I can force your system to do no more than whatever it's got capable at the moment. However, there's one more attack, and I'm running out of time, so I will go straight to the full one. Let me show you this one. This is, here we go, right. So, time out again. Yep, it timed out again. I don't know why it's timing out. Let me try that again. Let's just delete these. Right, so if I pick, sorry, it was a 2.11, I'll pick a Java version, doesn't really matter. And I do that, will it time out again? There we go, okay. So look, it says, thank you for your data. And in the LDAP server log, you can see information, version numbers, class paths, and things. So what happened here, and I will show you the code, we're running out of time, is I got, using that instruction, I got the application server to talk to my bad Jane LDAP server that sent back a series of requests, which it got responses, and then sent further ones back that allow me to interrogate the system and figure out what version numbers what versions of class paths and things like that, but also to run arbitrary code. The worst case thing is this situation where for the wrong version of Log4J, these older versions, this is the worst case. It's that trivial. So let me go back to the code because I want to let you see the code in action. And I apologize, we're running way out of time on this. Okay, so what do you see? So you're concerned about logs, I should just cover that. If I can't get the data out of your system but I can force your application to log data it shouldn't do into the log, then I might be able to attack the log. Because much as you may think that logs aren't accessible, well, occasionally they are. because people make mistakes. And you can go to Google and type in something like this and find all the servers that have unfortunately exposed their Apache logs on the internet, right? This thing's called a dork, D-O-R-K. There are many, many of them. You can go to exploit.db and find all sorts of searches that will help you find servers that are misconfigured. And there's a whole completely different topic on its own. So if I can do that, if I can force data to be logged that shouldn't be logged, then I'll be able to pick it out the other side. Right. So transmitting, sending data off, that's the next level, isn't it? If I can get information out of your server, that can be useful for me. Not just class paths and version numbers. Can I get environmental variables, properties, things that I know because I've scanned your code, or you're using a framework or something where this stuff is well known. I definitely can get your IP address because you're making a call out. Okay. And you end up with these sorts of things where you make, I put some data into your system, I cause Log4j to make calls. I get data back, and if the data contains another substitution parameter, then I can get you to make the call back. And it will keep doing that until eventually I decide to stop, or I hit something that doesn't work. Right? And gadget chains are the same, right? Gadget chain, this is a gadget chain. This is a hash map. And then I put in some data, okay, which has got some substitution variable parameters in, and I create some other stuff, you know, and I've highlighted that, you know, this is a nested list. It's just a set of Java objects. Now, good gadget chains are ones that will drive Java objects and drive method calls and things like that, but they don't have to. This is just as good, and I'll explain in a sec why. Right. So this LDAP call ends up with that object being returned in a serialized form, right? And then depending on which version of Log4j you're running, you get different results. So some Log4j versions will tell you that it won't work because hash maps can't be cast to Java strings, which is just, turns out to be a bug that got fixed. You might end up have nothing happen, okay? Or you might end up with it actually working, and then you can see the text. And that came from a gadget chain that I constructed and held on a remote server. That is a serialized form of data that gets loaded into your server. Okay. I can use that to do a DOS on you. Okay, because I can take something like this object thing, an object array. I can construct an object like that, but actually, because I can manipulate the serialization form, I can set the size of the object to be created by your application when it deserializes it to some enormous number. I could construct a serialized form that would mean you would have to have, you know, terabytes, multi-terabytes of data to actually construct it. And every time I got that substitution parameter into your system, you would make the call out, you would get a serialized form that you could not instantiate without running out of memory. That's a denial of service attack. That simple. And then finally, the arbitrary code stuff. We're lucky in that some cases it fails because of some of the bugs in Log4j, but again, that's at the end of the day, that was just lucky, right? If the object that came back when I made the call to the LDAP server was a reference object, and I'll let you look up what a reference object is. The most important thing is to understand that it's the name of a class and where to get the class. Here's a URL, different place. That class is then loaded, okay? And if that class implements the right interface, object factory, and with the right method, then that method is going to get called and run. So, and any objects that code wants is going to get pulled down, all the classes, and they're going to come from that bad server. That is complete and utter arbitrary remote code execution. If you can, if your server allows me to do this, then I can do whatever I want because I can run any code any way I want. Okay. And you'll never notice because let's go back to, let's go, yeah, because the hidden attack thing is at the end of the day, I'm having a conversation between two servers, the server running where the Log4J is running and the LDAP server. And as long as that LDAP server sends back something like a text string, that'll end up in the log. And you could never see that coming. Okay, I am going to stop because I'm sure there are questions. And I'm sorry, I didn't get anywhere to where I thought I was going to go, but I said you guys are all guinea pigs, so I'll do better next time. Let me stop the sharing. Okay, right, questions. Loads. What have we got?
There's a few in the chat, I think, Steve.
Yeah. Okay. Is it correct to say that the Java enabled Log4Shell because it somehow allows loading execute? Yeah. So there's Log4j with its own capabilities, which are bad enough, but the JNDI thing is obviously built into Java. So it's the mix of both. It was for the perfectly reasonable reasons, the Log4j guys added in this JNDI support, which said you can now make JNDI calls, but they hadn't appreciated how wide that could be. So basically, there are two ways to fix this. One is to turn off JNDI, which you can do. And the other way is to have a Log4j that doesn't do these, honor these substitution parameters. Three ways. Somebody's going through it 3 ways. Yeah.
There's obviously a third way, which is very strictly control which machines access the internet, right?
Oh, yeah. I wish that was possible.
First
I really do.
First
Yeah.
of all, I'm quite surprised that the community didn't think of this exploit before, but I'm quite happy that it actually got there because it may actually shift a lot of companies to switch
well,
to
so I have to show you one more. I've got to show you
inbound
one more.
gateways and outbound gateways model, right?
Yeah, I've got to show you
Where the
one
outbound gateway receives no traffic from outside, only from the internal services if you want to send the mail or whatever. And web-facing ones are the inbounds, and they cannot go outside.
That would be nice. Yes, yes. So I should point out that because we've got botnets in here, this isn't going to be, hey, I've got one server making 100 calls to another server. It's going to be the first call that my compromised server makes to the LDAP server will be a one IP address. I'll get a message back, which will tell me to talk to another one, right? So you will have a list of random IP addresses that that you might see. So to detect this, you'll detect it if you see in your log all these $sys things, which is good. But successful attacks are going to be really hard to detect because they can be done in such a way that you wouldn't notice. And when you've got, if you're going, are there any log patterns? Have I got any IP access patterns? If your server is talking to the outside world, or even to, it can be to any server, this is the problem, then you could be compromised. But that's not the bit that scares me, right? The bit that really scares me is something much more prosaic, which is we're not very good at fixing this. Right, let me share my screen again. Okay, because I want to show you one more thing because it does my head in. Right, so I work for Sonotype, okay, and I work for Sonotype because they're really serious about trying to improve Java security. Right, they've been doing it for years, and they have a bunch of cool tools which you can go look at. They are stewards for Maven Central. So they have all this data about downloads and they watch a whole bunch of other stuff. We are still, best case, seeing 40% of the downloads of Log4j are vulnerable versions. 40%, even after all this rigmarole about trying to fix it. there are still systems out there that are downloading, right, that are downloading older versions of Log4j. And that may be because they don't realize it, that they haven't got the message that it's important. But I'll also tell you that one of the reasons is that we are not very good at the tools that we use. And many people are relying on very simplistic tools to find their vulnerabilities. You know, you've seen things like, there are like, oh, use Dependabot. Well, Dependabot is good for direct dependencies, not transitive dependencies. So it won't find the fact that you're using something 5 levels down that's using an old version of Log4j. It ends up in fat jars, right? People construct things. Will your scanners look in a fat jar? It's not a dependency. No. You can use, the other people say, oh, you should use the dependency plugin in Maven. Okay. And there's some advice to use that. That does not work in a lot of circumstances. So what for me is the biggest challenge here is that what Log4j says is we have this big horrible problem which we have to fix. The best way to fix it right now is to patch your systems as soon as you can, but unfortunately we're not very good at working out whether we need to be patched, and we have to fix that because Log4j is not an isolated event. I only touched on it, but this is going to become regular, right? The way that the bad guys are behaving and their new motivations, they are looking for more and more of this, and it's just going to continue. It may not be a Log4j one tomorrow, it may not be a Java one tomorrow, but you can expect continuous attacks. And so we have got, as a community, we have got to get so much better at finding and fixing these things, because the next big Log4j thing, you know, could easily burn you. Yeah. Anyway, I will get off my high horse. As you can imagine, I've been living this since 9th of December, and I have Log4j eyes. So I would, you know, get to the point I'd like to stop talking about it, but I don't see that's going to happen in any case yet. Yes. Okay. Other questions? If we use SLF4j with Log4j, if you use SLF with Log4j, it is vulnerable. It is. SLF is just an interface. Yeah. Yeah.
With Log4j 2.
Sorry?
With Log4j 2.
Log4j 2, yes. Oh, yes. So I am talking about Log4j 2. Log4j 1 has its own issues, but different ones. That's a different talk. And if you're not running on Java 8, you're on Java 7 or older versions, then you have other problems as well. Right. Look, so the best thing is, if you like this, if you want to know more about this, and I would love to have this conversation with everybody, because I want to know your thoughts, where you've got with it, have you been affected? Go on the LJC Slack channel, or go to me on Twitter or LinkedIn and just say that you want to have a conversation. If there's enough people who are interested, then we could do this again, and I'll try not to be so rushed. Okay. Anyway, so I think we're at time. Thank you so much for listening. And
yeah, pretty much. That was brilliant, Steve. Thank you so much. That was so interesting to hear. You're getting a round of applause and everything. So well done. Yeah, thank you so much, everybody, for joining us this evening. It's been great to have you all here. As I've said, you can find the recording of this evening's talk on our YouTube channel in a couple of weeks, or my LinkedIn profile is in the chat at the very top as well. So feel free to message me on LinkedIn and I can send you the recording when it's ready. But from us at RecWorks, thank you so much, Steve, for speaking this evening, and thank you all for coming and joining us, and hopefully see you at our next event.
Cool. Thank you.
Have a great evening.
Bye then.
Take care. Bye.
Thank you.